give you basic information about some folders. So don't worry about it because they are not that important. But I will spend quality time on the important topics. Okay. So what is base folder? We have a base folder under the same directory. So basically, base folder is just a folder where you are keeping all your database related OIDs. Okay, if you go to the base folder, you will see the numbers, and these numbers are nothing but your, it represents the actual database files. Okay, so how to find that? If you go to here, we have three databases, right? Postgres, template1, template0 and all. So it is representing these particular directories. Okay. By any chance, what is template1, template0? Why I have these extra two databases every time get created? Let's take it as a assignment question in the next class. Give me the answer that why we need template1 and template0. Okay. Note it down this question. I will send in the group also. Okay. So base is nothing but a directory which is capturing your actual database folder, and under that folder actual table indexes and the database files are getting stored. Global, what is the global? So global is the folder where you are keeping all your database wide data like roles, database metadata and system catalog. Okay, so tell me one thing, one important concept. What is system catalog? Any idea? Or tell me one thing.
Configuration
Okay,
related files you keep, you mentioned.
okay. So let me explain it in the different database level. So in MySQL, we have performance schema. We have MySQL schema. So which is equivalent to system catalog. So in MySQL, we will call it as a system catalog. People who are from the Oracle side, they can understand these are the data dictionary table. In Oracle, we have data dictionary table, right? Right? Yes or no? Oracle DBA? Anyone? We have data dictionary and we have V dollar. We have what kind of dictionaries we have in Oracle? Anyone? V dollar DB underscore data underscore files like that, right? They are nothing but dictionary table. In Mongo, we call it let's suppose we want to see the replication break or something. So what we do like db.print.replication secondary bracket open bracket close. So they are nothing but they are also data dictionaries. So in other words, a data dictionary or system catalog tables are the table which holds the metadata of your database, right? Or the information about your database. Let's suppose how many users are there, how many tables are there, which index is there, which column is indexed or non-indexed, all those things. PG underscore wall. So what is PG underscore wall? Write ahead log. So in the next class after the installation, we will talk about the architecture of the Postgres database. So there we will talk about the wall files. So wall files are nothing but the log files. Whenever you are changing any data, let's suppose you are changing a table, a row inside a table. Let's suppose I'm updating employee salary from 10 rupees to 12 rupees. So basically I'm changing the data, right? So that change information go into write ahead logs, which is in the Postgre world, we call it wall files. In SQL Server, we call it log files. In Oracle, we call it archive log files. And in MySQL, what we call it? We call it log files, right? The MySQL.
Redo log files.
Bill
Redo log
logs.
files. Bill log files. So bill log files are the
So I guess bill log files are not for crash recovery.
not crash
Read
recovery.
it is redo log files which are used for crash recovery.
Redo log files are just a file which holds the redo data, but mainly the changes goes to the archive log in Oracle. MySQL, it goes to the bin log files, and in Postgre it goes to wall log files. Okay, we'll discuss more in the detail. PG underscore extra exact. So PG underscore exact is a folder where we are just putting the transactional track, basically what kind of transactions are getting committed. If any transaction is getting aborted or it got disconnected, the information goes there. Also, it maintain the track history using asset property. So how many of you aware of the asset property? So we in the further classes, when we will read about the isolation, we are going to read about two main concepts called cap theorem and asset. Are you aware of these two terminology? Anyone? Cap theorem and asset?
Acid,
Yes.
I had idea, but
Mhm. Okay, so just make a note. You have to give me the answer of the question why we have template database in the Postgre. Second thing, read about cap and asset and just explain me in the next class. Anyone? Or as a group also you can explain me. Cap theorem and asset, it's one of the basic thing that we have to do in terms of database administration or development. PG underscore subtrans, it holds the transaction information and it is also tracking the your internal save points or internal transactions. So let's suppose in your code, if you are making any save points, you are making anything like let's suppose you are for a transactional purpose, you are taking a old image of your data. So that particular information goes to PG subtrans, PG underscore commit underscore TS. So this is particular, this is the folder where we are keeping all the transactional data which got committed with the timestamp value. So that if you want to refer any of these things in the future, you can go to this folder and you can see which particular transaction got committed. Okay, so now you will ask me that we have multiple folders, which is the most important folder that I should be reading about. So my answer would be PG underscore wall. This is most important folder that you should understand. Okay, rest all are is just okay to understand, that's all. Additional folder that we should be understanding. So the log, it is very important. All the Postgre related logs are going into the log folder. Related to log, I want to tell you one thing, that we are not going to use the traditional logging method. In one of my class, right after the installation, currently these logs are very basic level logs. They are just capturing the basic logs. But I will tell you a way you can make your logging much more better and you can capture more informations. Currently this log is very basic log. So we have a lot of configurational changes that we can do in our postgre.conf and we can capture better logs for the future troubleshooting purpose. So there is a chapter called logging. So there I will explain you how you can configure your Postgre so that you can capture more logs. So currently what is there? Currently it's a basic default logging. It is just giving you the default logs, whatever happens to the system. But we will make it more professional. We will make it more production ready logging system. Okay, in the future classes. PG logical. So basically in Postgre, we have two kind of replication system. Logical replication and physical replication. Same like Oracle, same like SQL Server, same like MySQL. Okay, in MySQL also we have multiple kind of replication system, right? What is replication by any chance? What is replication? Basically, we are replicating the whole data from one server to another server, or mean to say we are doing mirror, which is nothing but copying the data from one place to another place. It is nothing but replication. So replication have two types. If you are doing block to block replication or file level replication, which is considered to be a physical replication. When you are doing a replication on object level, mean to say you want to only replicate a certain part of your database, like this table you want to replicate to the other database, only one table, it will called as a logical replication. Okay, getting my point? This is physical replication, this is logical replication. So all the logical replication related metadata goes to this particular directory called pg underscore logical. Okay, so whatever currently this might be empty now or there is no data, only default data is there. But the moment you will configure logical replication, you will see the slot related information under these folders. Okay, so logical replication is part of our course. We will configure and I will show you how it works. PG stats. So basically PG stats captures all the statistics related to your storage, and it is used by your catalog tables basically. So whatever statistics like what is the storage you have, what is the free size, what is the use size, all those details goes to this particular folder, and later it can be consumed by any third party operation or it can consumed by Postgres internally. PG underscore temp underscore stats underscore temp. So basically PG underscore stats underscore temp is nothing but it captures your temporary runtime status. So what is running currently, which query is running, what is the mathematical operation the query is doing, all the statistics which is temporarily needed goes to this particular folder. PG underscore notify. Okay. So basically notification is one of the system where the Postgre processes are getting notified by each other. Let's suppose I am doing vacuuming, I am a process, I am done. And the moment I'm done, I will write a notification file, and this notification file will be consumed by other backend process. Okay, so they are just creating a semaphore kind of configuration. Anyone understand semaphore or lock files? Do you understand this concept? Yes or no? Semaphore or lock files. Okay. Let me give you a scenario. Every day I want to run a job. This question is related to backup. This question is related to data engineering. Every day I'm running a job called A. A job takes 2 hours to run. Okay. After 2 hours, again, I have a job called B. It's supposed to run. But today what happened? My A job is still running. 2 hours are over and my B job is also got triggered. Okay. So the problem is when my A job runs, it consumes a lot of CPU. My B job runs, it also consumes a lot of CPU. So without understanding whether A job got finished or not, my B job also got triggered. Okay, now both the jobs are running and both are locking each other or both are using a lot of CPU and memory. Second thing, internally my A job is interdependent with the B job. So B job doesn't have any cleverness or intelligence or something to check whether A job has finished or not and should I start or not, right? There is no internal dependency or something. To fix all these things, what we do, we create semaphore or locking files. So mean to say, whenever job A is getting executed, it will create a file called temp underscore lock underscore job underscore A. So this job is running. Now, until unless this file is existing in the temp location, job B will not getting executed. How? In the job B, internally, we will write a logic. If you see this file, don't get executed. Mean to say this is the done file for a job. Mean to say once this job is executed, this will remove this file and job B will go and check whether the file is there or not. So if job B will find that there is no file, it will start the job B. So what we are doing here, we are creating a lock file. We are creating semaphore. In other words, we are creating done file. Right? In the backup also we do, right? When we are taking full backup, we create a temp file so that next backup is not getting executed. Is this clear? What I'm trying to explain here? Mean to say, to prevent the multiple execution of the process, job or backup, we create lock files or semaphore files or done files. Is that clear?
We have to create these files manually, or it is default?
It is,
When-
let's suppose you are taking a backup dot sh. Let's suppose you have created a shell script. So under the shell script itself, you will create a dummy file called touch /temp
राम भाई शाश्वत
slash
शाश्वत यार वो ओनर का नंबर दियो एक बार
java1.log like that.
उससे अरे वो ही पूछ
Okay.
रहा था यार वो इस हफ्ते
Dhirendra,
आर्टिकल ला सकता हूँ तो
you have to mute yourself. Okay. So like that, once I have log file, what will happen? My next execution will not start again. So what it is doing, it is checking whether the first execution has finished or not. So how it will check? It will check this job file. So whenever there's a job file exists in the temp, it will not execute the next job. So like that, we are creating interdependencies, and these dependencies are not what kind of, these interdependencies are sometimes it called as a queuing. Okay, all those things we create right in our automations. So this is nothing but same like your background queuing process. They notify each other using semaphore locking, or there are multiple other algorithms. Okay, but is this clear? In future, we are going to use it, lock files, semaphore files, or done
Sir,
files.
if they are notifying, then how it is benefiting like for the other
Okay.
jobs?
Okay, so let's suppose you have only you have one for example, what is the benefit? Let me tell you. Let's suppose I have only 32 GB RAM on my computer. Okay, and one process is running. Okay, let's suppose this process one is running. It is consuming 16 GB of RAM. Internally, it is consuming 16 GB of RAM. So now next process also want to get executed due to XYZ reason. Okay, so let's suppose the second process is going to consume 32 GB RAM. Do I have that much of RAM available in the buffer? Because already one process is running 16 GB, another 16 GB is free. That out of that 16 GB, 4 GB is already occupied by OS or something. So once this job will get executed, it is going to get the appropriate RAM amount of RAM? No, right? Because it needs more RAM or more process, right? To fix all these internal issues, when we develop the programs, when we develop the memory architecture, what we do, we create internal notification systems, or at least we create some kind of internal systems which get notified by each other. Mean to say this process will wait for this process to run, or if this process is going to take long time, this process will get switched to swap memory. The moment it will get to switch from swap memory, 16 GB will get freed, and this process will start executing. Okay, in other words, let me tell you one thing. In my computer, how much RAM I have?
64 I think.
64 GB. How many programs are open? A lot of programs are running, right? If you see the worth of program which is open, do you think 64 GB RAM is enough? No, it is not enough. But how operating system is handling this memory management? Is all the memory is getting occupied? No. It is only occupied where my active programs are running. So who are my active programs? This is my active program. Teams is my active program. This is my active program. What about the other programs? So other programs are not getting directly loaded into the memory. They are just into the queue. The moment I will click into that program suddenly come into the main memory. That's why I'm managing 64 GB of RAM or any GB of the RAM. And that's why Windows are using these kind of systems. If you read about all these things, you will understand a concept called swap. Okay. So these are nothing but notification system. This is a concept of operating system. So backend processes are basically nothing but memory process, or they are memory buffer area. When we will talk about the architecture, I will explain you all these things in the deep, that how to understand all these things. Okay. In other words, you have a stage, right? This is the stage, and there is a program going on. So the program which is currently running, let's suppose they are running a skit or they are doing some kind of play, right? And you have only, let's suppose you got only some amount of square feet in the stage. Okay. So only one program can run, right? Here. So what happens? The program which is going to be executed, or the program who is next, what they do, they stand here, right? Next to the stage, right? Right?
Yes.
Yes or no? So when their turn comes, they moved into main stage. And what about the old program? Where they go? They moved into right hand side, right? Because their program is done. The moment if they want to execute the old program again, what will happen? They will come into the main memory again, right? And this guy will go back to his place. Or not only the all program will not go, at least some part of his execution will go back to the swap, or it will get ended. Same thing happens here. If you see the processes, can you see all the processes are using memory? Just see here. All the processes are using memory. They are using, but the moment if I click on Firefox, my memory utilization might go high. The moment I will use OneNotes, my memory utilization will go high. CPU, only few programs are using CPU because they are the active programs. We will understand more when we will understand the architecture, because I'm going to teach you some of the operating system concept also, so that you can do better performance tuning. Okay, we'll discuss that. But is that clear in high level, at least? Backend process, queuing system, all those things. Okay. So the major takeaway of your this session is going to be, you should focus on postgre.conf, hba.conf, postgreauto.conf mainly. Data storage, you can focus on pg underscore tablespace. Pg underscore tablespace is a folder where we are keeping the table spaces, Postgre related table spaces. Okay. So what are the table space? What is table space in the database level? What is table space?
Logical name for a physical location.
Very good. Very good answer. Logical name for a physical location. So what problem I am solving here? What is the biggest problem I am solving? Creating table space. Anyone? Just think like an architect, OS architect. Don't go into the database. Just think like a operating system architect or operating system sysadmin. What is the biggest problem I am solving? This is my database.
I think
All
storage.
of my storage is there, but there is another important thing. I will just explain. DB, and I have disk 1. My all the DB related files are residing in the disk 1. And let's suppose this database is related to Amazon. Millions of users are 1 million, 2 million users are using my website, and that load is also coming to my database. Do you think is this a current scenario? This architecture is a good architecture for Amazon like website, Facebook like website, or LinkedIn kind of website? I have only one disk. This database have multiple databases. Let's suppose it has sales, HR, and finance. All the data is going to my disk 0. Is this a good architecture? First of all,
No.
No.
so what will be the better architecture to support the application like Facebook, Amazon, Google, where multi-million users are connecting from different continents? How we can plan this in a such a way that we are able to manage it in very good, optimal way, or we can give good performance. What is the major problem that you see in this architecture? The major problem
Or
is
if disk
my
fail,
yes, my disk fails, everything will go. The another major issue is I/O. I have very big amount of input output going on my single disk. Okay. Now, to make this architecture better, what I will do under my database, I will create table spaces. Tables, let me make it table space like sales TB, TBS, HR, TBS, finance, TBS, table space. And these table spaces are going to connect with to a different disk. This will go to disk 1. This will go to disk 2. This table space will go to disk 03. Now, what is the betterment of this? Like this is version 1 and this is version 2. So what is good, or what is the improvement we did in version 2 using table space? What I am achieving here? Anyone?
we are dividing data on the basis of a department, something like that. And we are reducing this IO also.
Right. So first of all, previously my all the database was going into my global table space, single table space, and single disk was there. So I was getting a lot of IO. So what I did using Postgres table space method, I have segregated the data and data storage into multiple disks. Same thing we do in Oracle also, right? People from Oracle side can answer, right? In Oracle also we have table spaces. MySQL new release, I don't believe they have introduced table space 8, right? MySQL 8 has introduced, if I'm correct, right?
I don't know.
You don't know? Okay. So table space is nothing but database, table space. So basically you are logically managing your data using table space, and you can further segregating your table space into multiple disk. So what we are achieving here, we are achieving better performance and we are reducing the IO, right? Let's suppose I have a scenario. I have three database. I have DB1, I have DB2, and I have sales. Majority of the time, most of my database queries or most of my database load is coming from this database. And users are not happy with the performance. I want to further, and I am also getting a lot of IO or IO bottleneck. Can I segregate the only this table, this particular database tables to a separate disk? Is that possible? Yes, it is
Mm,
possible. If you see the V2, what I will do, I will create a dedicated table space for sales, and I will move all the objects of sales to this particular table space. And I'm going to get very good input output performance. So that is the main purpose of table spaces. Is this clear? This is important concept. That's why I'm asking. Is this
So,
clear?
sir,
Logical?
as you're mentioning table
Mhm.
spaces, we are creating every separate table space on a specific disk, a separate disk.
Correct.
सर बट वी जनरली गेट अ सिंगल माउंट पॉइंट मतलब सिंगल स्टोरेज ही तो हमें मिलेगा लाइक
See, no, you get a single mount point that that I know. But in a bigger system or in a bigger database environment, you want to segregate your IO. You don't want to send the same IO to same hard disk, right? So what you do, you just channelize your load or database IO to a different disk, right? For example, let's take my example. My all the database load is going on which disk? Only one disk, right?
एसडीए
Is this a correct good architecture? No, it's not a good architecture.
ओके
My whole load is going into only one disk. It's not a good architecture. What will be the good architecture? And also on the Postgre level, all of my database related things are going into single database, table space, PG default. Okay. So is this a right architecture? No. How to make it good? For example, I have a new hard disk which is mounted on let me practically show you. So now I have a logically think like it's a new hard disk. Okay. And take my this example. My sales database is getting a lot of load and I'm getting a lot of IO issues and all. Okay. I did a mistake. Let me change the ownership also. CHO slash opt disk. Now I think it's better. Okay. So now I have a new hard disk. And on the Postgre level, let me go there and I will create a new table space. Create table space. We have a dedicated chapter also on this, but as we are talking about, let me give you a small brief location and I will give this as my location. Okay. So table space is created. Now I'm going to create a new table and I will mention that all the tables data will go to that particular location. Okay.
okay
Is this looks good? I have defined a table space. So now what is happening here? Anyone? What I did just now?
सर you have assigned a table space for this
To a
sales
different
database
to a different
toward the
different
different disk.
disk. So when the query will run for the sales, on which disk IO will go?
OPT, OPT
OPT,
disk one.
with OPT disk one. So if I have let's suppose I have 1 million or 2 million users, and this is my one of the the busiest database. So what I'm doing here, what I did, I have channelized my IO from this disk to this disk. In other words, in my example, I have channelized my IO. My whole database was running from disk 01. Now I have created a new disk and my sales tables are using a different disk. So what is happening when my disk is changed? My IO got segregated and I'm going to get the more better performance. We'll discuss more when we have a tablespace tutorial or the session. I will give you the more information. But is this clear at least what I did just
Uh,
now?
a little bit. But sir, if we are creating multiple table spaces,
Mm-hmm.
but their location is same. Say for
Mm,
example, slash OPT, I have
mm,
created
mm,
another,
mm,
like the storage or mount point is
mm,
same,
mm,
but
mm,
I am creating a different table space
mm,
for
mm.
every database. So is it the same scenario, the one we were
Mm,
having previously, or
mm.
like will it still be a good approach? Because आपका underlying storage is same.
Correct. Let's create a thumb rule so that you will understand it more. The usage of table space. The first one is, what is the next thing that we are doing using table space,
Performance,
right?
storage separation, okay.
Maintenance.
Maintenance is
So we are doing multiple. If my database is having multiple table spaces and if one of the disk is going for maintenance, at least my main database will not get impacted. Another thing, using the maintenance option, we are also channelizing and using disk failure system, which is nothing but RAID kind of system. You know about RAID, right? Where we are just single hard disk. Underneath, we have two hard disks, main and primary and secondary. This is my main hard disk, logically main hard disk, and underneath I have primary and secondary. So if my primary hard disk goes down, still my secondary is serving the data. So these kind of thing you can configure under the maintenance. Biggest issue that I'm fixing is space management. People who are from the system admin background, they will understand this. First of all, let me do a vote because that is more important. Are you getting this option? Sorry, concept, whatever I'm trying to explain here, table space. Everyone, yes or no? People from the Oracle side, they must be
yes.
understanding it easily. But I want a vote so that I can talk more on these. Everyone is understanding?
Yes.
Yes, sir.
Okay.
Yes.
So basically, Dhirendra, if you're not understanding, don't say yes. You can say no.
No,
That's why we are
sir,
here.
partly like I'm understanding, but you said now we'll be
Mhm.
discussing this. But whatever you have explained, I'm getting that much.
Okay, okay. Then I think we are good, right? When we have a session called how to configure Postgre for production system. These things will come again in that topic. Okay.
Okay.
Just make a note to read about cap and asset properties. This is important. From interview point of view, all the big companies, Amazon, Google, Facebook, Meta, they start their interview with cap and asset only. So these are important for DBS to understand. Cap theorem and asset property. If you simply go to the Google and type cap theorem, it will come. This is the cap theorem and asset properties. Okay, so we have to understand atomicity, consistency, isolation, and durability, which will come into the further sessions also. But but are we clear so far? Table space, transactional control, the tables, all the replication, all these things are important. Are we understanding this, at least basics, why we have these folders? Everyone, at least basics, do we understand?
Yes.
Why we have these folders and files? Basic is clear at least.
Yes.
So out of these files, let me tell you which folder and files are very, very important. Okay, so this folder is important. We should understand about this pg@bh.con, pg-ident.con. It is important, but not that confident. These two files are super important. Log files are important, and pg tablespace, pg logical is important. Okay, so you read or do things according to this order. Yeah, Sudeep, tell me.
Sir, this PG logical, it is related to replications,
Replication
replication,
only.
right? Yeah, is
Replication only.
that possible to like to change the different directory? Is there any chance?
Yes, we can do a lot of changes in PG logical. So PG logical, it's a basically when we will read about PG logical, we will read the logical replication from CDC point of view. I don't know how many of you know understand about CDC. Change, data, capture. So we'll read about from this particular point of view, and we will understand about all these things. Not only Postgre replication method, we will understand about Kafka and database pipelines, because that is also very important in the new and emerging database administration. All the AI and ML related thing happens through CDC also. So we should be understanding those concepts. Clear? So I will talk about CDC also when I will teach you logical replication. Is that clear? At least
Yeah, yes, sir.
from the full name point of view, we are clear. Change, data capture, or logical replication. Just to do the Google. Are we good?
Yes, sir.
So we are going to talk about all those things, and directory can be changed. It is possible. There are some important notes which you can read, and that's all. I think that's all in this session. In the next session, can I take 10 minutes more? Because if I take 10 minutes more here, next session is going to be very easy for me. Okay, everyone agrees? You have 10 minutes more. I will quickly explain one topic so that our next class will be, we can save time. Okay, so I think in the beginning of this class, we have talked about the platforms and versions. So can someone tell me quickly how many type of Postgre databases or versions or flavors we have in the market? Quickly,
We
if you
have
remember. Hmm?
Percona,
We have Percona,
we have EDB,
EDB, Community Edition, like we have AWS
AWS,
Aurora.
Aro,
Yes, Aurora.
RDS,
Anyone else? Raj?
Azure,
Azure, Google Cloud
Google,
provides their own.
Google. There are a lot of things. Heroku is there, like that. Okay.
okay.
What about the
Yeah.
common platforms we have to install the Postgre?
CentOS,
Linux.
Red Hat, Ubuntu, Rocky
Okay.
Linux, Alma Linux.
Okay. VMOS container.
Do we understand all these things? VM, OS, container, Kubernetes, cloud, hardware, at least.
Yes. Yes.
Okay. So majority of the time we are installing on VM the way I'm doing using Vagrant and all. So under the VM we have VMware, VirtualBox, OS. I think you already everyone knows Alma Linux, Rocky Linux, Windows and all. Containers. This is important, which we will cover. I will cover Docker and Compose both. Kubernetes. Do we understand Kubernetes? It's okay. If you don't understand also, we have it is in our class. I will explain you. Cloud. What are the cloud platforms we have?
AWS,
Azure,
Google,
AWS,
Azure.
Google Cloud.
Azure. Okay. Hardware. We have so many hardwares also. Like we have Raspberry Pi. We have direct bare metal hardwares available where we can directly go and install Postgre on top of that. Okay. So Postgre comes with the light edition also, which you can directly install. So even the satellites which goes to the space, they also use databases, and where we can use Postgre databases. So being a DBA, our main direction of learning will be like this. Okay, majority of us know VM, majority of us know OS, but in this class, my main focus is going to be on these two places and this place. First, second, and third, because these platforms are emerging into the market and lot of demands are there. The people, the DBA who understand Kubernetes have more value than a core DBA. Yes or no? Do you agree with that? Or a DBA who understand Docker have more value than a core DBA, right? Everyone, thumbs up
Yes.
if you agree. If you disagree also, you can tell me that no, Abhishek, I don't agree with you. It's not correct. The person who knows at least these three technologies, at least cloud, Kubernetes, and containers, are the next level DBAs, and they will be in the market. Core DBAs might get reduced day by day because core DBA administration can be done by a level 1 and level 2 people. Okay, so our whole course focus is going to be on these three places, and my whole teaching is going to around on these platforms. Okay, where I will use VM most of the time, but I will refer container, Kubernetes, and cloud also multiple times. And my technology sessions are just evolving outside of these topics. Okay. So in the next class, I think VM installation of Postgre on VM, can we skip? Or you want me to show that also? Just yes or no. So on the VM, basically we have two kind of installation, manual installation and automated installation. Automated installation, I think we have already seen, right? Using Vagrant. Yes or no? Manual installation,
Yes.
if you want, I will show you how to do that. But let's do the Postgre installation on Docker first and understand all the Docker related concepts. And then we will go to the next level called Compose, Docker Compose. And I will give you a basic idea about Docker Swarm cluster. Basic idea. I'm not going into much deep, otherwise it will be confusing, but at least Docker Compose I will cover in the context of Postgre. And in the later part, Kubernetes we will not do right now because it is little confusing. When we will do our Postgre classes are done, then we will go and touch upon Kubernetes cluster. When we are doing clustering part, right? Petroni cluster, Kubernetes cluster, EFM cluster, that time we will start learning and start building our own cluster or Kubernetes, that I will capture later. But cloud part, let me show you at least the AWS RDS, the basics of AWS RDS, which is easy and I can show you in within a one session. Okay, and if everyone is agree, I can also show you on Azure, because I personally believe that Azure is also getting popular in the market after AWS, and the way Azure is going ahead, I think Azure is going to have more weight than AWS in the future. That's what I can see. So everyone should also start understanding about Azure. Azure gives you a free certification which anyone can go and obtain it. If you just type free certification, they have very good portal. There you can just go and explore on their the certification model and just try to get a basic Azure certification, which is free. Okay. So if you go here, they will explain you all these things. And I think their Azure fundamental beginner certification is free. Anyone can go and do it. Okay. So try doing it. If you want the step-by-step thing, I will send you a document also. I have a document. But if simply go here, learning path, and you can just get their free certification. They have a lot of free certifications available, and you can start understanding about the Azure infrastructure. People who are from the AWS side, it is very easy for them to understand Azure. Very, very easy. It's just a name and the reference point change. In Azure, we call it Postgre service or Postgre managed service. In AWS, we call it RDS. So that kind of small differences are there, but overall core technology is same. Same like GCP. Okay. If you understand AWS or Azure, you can easily understand GCP Cloud SQL for Postgre. It is very, very easy. Okay. But my main focus is going to be on Azure and AWS. Is that clear, everyone? Is this clear? At least what we are going to do in the next class?
Yes.
So first, I think I have already talked about VM and Vagrant. My next topic that I'm going to pick up is like manually I will show you how to install Postgre. And after that, right after that, I will start talking about the Docker because Docker is very important. Okay, is that clear? And when we will do the Docker practical, I will show you, we will talk about two important software also. One is Portainer. We will talk about Portainer because Portainer is a graphical software that we use to manage the Dockers. Because all the big companies are not managing their Docker just using command line. So it's nothing but people who are from the Oracle, they can think like this is a grid infrastructure software or enterprise manager. People from the MySQL side, they can think like it's a enterprise managing monitoring management software, or it is Prometheus or Grafana or PMM. Okay, I'm going to talk about Portainer. I will also going to talk about Rancher, so that how easily you can manage your Docker using the graphical user interface with the very less issues. So we'll talk about all these softwares also a little bit so that I'll give you the overview. So whenever there is a chance, you can use these softwares. I'll tell you how to install also. Okay. Within a second, I will give you some tips and tricks. You can build your own environment. So under the Docker, we are going to talk about the softwares, how to manage the Docker. We will talk about the volume. We will going to talk about the persistent volume, networking, and Docker image, and how to run a container. Okay, all these things in a very easy way. Okay, we are going to talk about in the next session. Make sense? Looks good, everyone?
Yes, sir.
Do you think it is going to be useful, everyone?
Yes.
I have another
Yes.
issue from everyone. A lot of people are not speaking in the class. So at least if you are not clear, you want to speak about any topic, you are just feel free to, you can bring any topic, we can have a discussion, but don't hold your questions, okay? Because these things are very important and they are interrelated for the future classes like table space. Okay, in the future classes, table space might also come. That time, if your concepts are clear, it will be very easy for you to understand these concepts. Okay, so don't hold your question. You can ask about anything. You can even say, I'm not sure about that, what you're talking about. You give me some background about it. So I'll give you more background because end of the story, it's my job to make you understand about all these topics. This document I will send you via WhatsApp. You can get it. Another thing, I want to have a discussion, small discussion, like how many of you has not paid